Yeah. So now see here. So what we were talking is the plain polarized light is being passed through this. So you have kept the water in the cell, and then pass a plain polarized light and adjusted your this one the this is the analyzer and this is the polarizer. So through the polarizer, you make it a plain polarized light that is passed through the solution, and then you're allowing to pass through the analyzer slit. Now, you take this cell out from the machine and remove the water and add optically active compound and replace it here. Okay, optically active compound solution you have put inside, and see here your slit is like this. Now you have put optically active liquid, active substance. Now pass through this. Again, the light will enter. But if you look now from here, you will see black. That means you are not able to see the light which you were seeing in the initially when it was water. That means the plane has changed. Light is entering to this, but it is, see here, it is moving, it was moving in this plane. Now it is slightly rotated. Now it is moving this plane. That is why now, see here, it is not getting, it's not coming out through this. What you do is, you rotate this light, this slit. When the slit is in this plane, slowly rotate it till you see the light coming out. Slowly rotate it till you see the light coming out. The moment you see the light, stop it at this point. Okay? Now measure this angle. This angle, and that angle is known as observed rotation. Observed optical rotation. Now remove this tube, remove the optically active compound, add water again, and keep it here. You will not see the light. What do? You rotate this back to the vertical position. This vertical position is taken as 0. When it comes back to 0, you can still observe the light coming out. That means your optically active compound is rotating the plane of the polarized light through this angle. Okay. Now there are certain optically active compounds, which you have to rotate the slit in the opposite direction, in the anti-clockwise direction. They are known as levorotatory. The earlier this is called dextrorotatory. So when you have to rotate right side clockwise, the compound is dextro, and the one which is rotating to the left side is levo. Okay. So this is what is meant by optical rotation. Now, I think within 2 or 3 minutes that this will stop. We will just continue for another 20 minutes. Okay. After the class, this is getting disconnected, please join again. Now, so this is the experiment. So those compound which rotate plain polarized light to the right is called dextrorotatory or D or plus, and the one which is rotating to the left side is levorotatory, LEVO, or it is minus, short L. Okay, and remember, this is an experimental fact. Experimental fact. You have to take the compound, a small amount of the substance, take a polarimeter. This instrument is called polarimeter. And prepare a solution of this compound and then measure the optical activity and see whether it is right or left. Now, simply by looking at the structure of a molecule, you cannot say whether it is dextrorotatory or levorotatory unless and until somebody has already determined it. And somebody has already reported this in the book or journal. Okay, if you have a new compound, there is no structural relationship. There is no relationship between the structure and optical activity. Okay, structure and optical activity. There is no direct link. Only thing is, if you have one compound, say for example, CH3, CHOH, COOH. This structure represents two compounds. One is having this, three-dimensional structure, CH3. We know all these things. H, OH, and COH. The other is having this structure. Remember, this is a mirror image of the first one. These two are the structures of two compounds representing this formula, this planar structure. If, and remember, this is just a mirror image of this. Okay, and these are called enantiomers. If this one is dextrorotatory, remember this, if I'm putting this, if I don't know. If this is dextro, then this has to be levo. That is sure. But if this is dextro, definitely this has to be levo. That much we know. But we don't know by looking at the structure which is possibly levo, which is possibly dextro. Unless and until we have a sample of this compound, take it to the laboratory, use polarimeter, and find the optical rotation. Is that clear? This is basically what is how to measure the optical activity